Hey, welcome to OT Asset Management Weekly. Today we'll talk about a more technical topic, which is the OT-based data model. And why would that be interesting, even though you might not be a developer? Well, just to understand how a contextualized OT asset inventory actually comes together, what that means when you have different dimensions to cover, how this is all represented in raw data. And we will get to the raw data, I will promise you. So before we go to that data, let's just look at OT-based inventory. To just give you a quick update, what it means to have a contextualized OT asset inventory. So this is the devices list in OTbase, where you have one row in the table for each asset or device. And you already see there is a lot of contextual information, such as the physical location of a device, the OT system that it is associated with. You can think of that as a work cell, for example. Then you have the network association and all the device details, such as the lifecycle stage of the device and the lifecycle stage of the product, which is a different thing because that product might be end of life, as you see here in those examples. Then you have other contextual dimensions, which you see displayed in the sidebar to the left. So, for example, there is a software inventory. And the interesting thing about that software inventory is now it gets complicated. Everything is tied together. So, for example, when I check out this just randomly picked software product, I see right away where it is actually installed. So this is how it is linked together. Same thing for the other contextual dimensions. So here is the systems inventory in OTbase. You see the various sites, you see the various, for example, machine lines or plant components. And again, if I single out a particular area and do a drill down, then I would see all the endpoints, all the devices. So again, you see how it is all tied together. Same for the networks. This is the network inventory. I just pick a random network here, do a drill down, and then I see all the endpoints in that network in an address list. Finally, the physical locations, the geolocations, same thing. I have my flat rock facility with its different buildings, rooms, cabinets, etc. And anytime I want to see more, I do that drill down, and I am going to see all those endpoints there. Okay, so that gives you a high-level overview of these various contextual dimensions. And now we look at the data behind it. So this is from the OTbase product documentation, which, by the way, is publicly available. So if you just go to support.langner.com, you will see the full product documentation. And in the section for integrators and developers, there is one particular chapter that is called the Portable Inventory Data Format. That is a data format in JSON developed by us that allows you to represent and share asset information, contextualized asset information with other applications, with other platforms. So that means just forget about the whole user interface, forget about the diagramming, the charts, etc. This is the raw data. And now the interesting part is, how are the various contextual dimensions represented in this data model? This is what you see here. So this is a brief description of our data model for a given device, which in OTbase is the foundational asset, if you will. So here is how this looks like. For each device, you have a couple of fields, and those fields can be complex, which means they can be objects. And you will see that, for example, here with this hardware field, this hardware field has its own subfields. Same with the context, same with the connections, etc. But let's just go step by step. So here you have a device ID. That's a unique identifier for the device that the user can change if they want to. This is what you see here in this column, device ID. And OTbase, if you don't set anything, OTbase will automatically create a device ID for you, which makes some kind of sense. So you will see the device type represented there. You will see an enumerator. But you can also change the device ID if you don't like what you see. You can use any device ID you want, probably representing an existing nomenclature. The important thing is that this device ID is unique. It must be unique. OTbase will enforce that it's unique so that you can establish device identity, which means, for example, you will be able to track configuration changes over time for this device, which is obviously very important. You will be able to track any firmware updates, any security patches for a Windows PC, for example, any software that was added or deleted. This is what you are all going to see in a device's timeline. And this certainly is only possible because in OTbase we establish device identity. So you can be sure that there is one entry for each device. And even if the configuration for that device changes, it's going to be associated with that same entry. So then you have a name which is different. That's the, for example, the host name or the DNS name of the device. Then you have a description which is usually edited by users. So here you could, as an example, record the exact purpose of a device. So for example, when you think about a particular RTU, you could say, well, this RTU connects to the drives or VFDs on machine line 5 or station 65. Then you have the installation date, the stage, the lifecycle stage of the device, serial number. So this is discovered automatically. The network zone, the safety certification, which in OTbase is something different as the criticality. So you could tell OTbase, well, this device is critical because it's it has a safety function, but that's something different than the safety field, because here this just expresses any certification that the device might have, such as SIL3. The timestamp when the assets configuration was last modified, this is automatically maintained by OTbase. Exposure, the network exposure of the asset. So if OTbase picks up data flow, and it should, so the capability is there, you just need to enable it by sending NetFlow traffic to OTbase, for example. Then it gets really interesting, because this field, this exposure field, will tell you right away, just as an example, if that device has communications with the public internet. Then you would see there, you would see the value public in there. In the UI, it will then also be highlighted in orange, because this is obviously something that you don't want to see in an OT environment. So very simple to process. You would just see, well, exposure is public, or at best case, it's local. The third option would be private. That tells you, well, it's communicating with other devices in other private networks, but at least not in the public internet. Hosted on. This is about virtualization. Then you can add any number of tags, totally user assigned. This next hardware object here, this is about obviously the specific hardware that of this device, the vendor, the model, the type. All that is discovered automatically by OTbase Discovery. So type could be PLC, it could be AC drive, it could be camera. Then the next field is category. The category is used to combine multiple types. So for example, when you think about network switches, there is one category, I think it's called network gear or something, where you would find firewalls, L2 switches, L3 switches, gateways, etc. So if you want to have a more consolidated representation of these various device types, then you have the hardware version, the order number, all of that is discovered automatically. End of life also automatically using the metadata push that we do once per week to OTbase inventory. Safety certification and product lifecycle stage. Product lifecycle stage, again, comes with the metadata push. We discover this automatically for you and then flag obsolete devices. And again, so just consider this is all the data that you will be able to pull from OTbase in JSON. And certainly that makes integration very, very simple and very powerful, because you get all this information associated with that device entry. Okay, so the processing becomes super simple. Next object is context, the location name, then the location identifier, the reference location, that would be usually the site name. And why do we maintain different fields here? Because the location, that could be a control system cabinet in a room, in a building, in a site. And certainly you will also want to know if I just want to quickly address the site. So for example, you want to do a report about the devices in all devices in one particular site, then you would focus on this reference location identifier. So that makes, again, processing so much more simple. The OT system associated with the device group. So this is another contextual dimension. In OTbase, you can define device groups, whatever you like. You know, it can be OT versus IT. It can be green versus red, or Siemens versus Rockwell. Just be creative, if that makes any sense for you. The process associations. So you can tie a device to a particular physical process, which could be, I don't know, the frame, the press in the body in white building, something like that. Connections, this is more technical again. And this is also automatically set. All the network connectivity that is automatically discovered and consolidated by OTbase. Or for each entry, you will see network name, network ID, network address. You remember that network inventory. Let's quickly go back there. So this is how the network inventory looks like. And for each and every single network, you will see the physical location of the network, a network name if you bother to set one. Otherwise, it could just be the network address. But the network address is going to be exposed anyway. This is what you see here in this column. This is automatically discovered by OTbase with the net mask, with everything. Well, because guess what? Well, this is what active discovery yields. You can establish the network identity. You cannot do that with passive sniffing. So this is what you will see here in the data, the network address of that particular connection that this device is connected to. And certainly, as you all know, a network in the OT space can be connected to multiple networks. And then for that reason, this is an array. This is a list. Okay, so there can be one entry in that list. There can be 15 entries in that list. Oftentimes, it's about 2 or 3. So then you have the network type. That very important in OTbase. You don't just see IP networks. You also see profile bus, or so talking about other field buses. You would see control net, device net, you name it. Data highway plus. The physical medium is that copper or fiber. L2 address, that would be the MAC address of the network interface. L3 would be IP. Interface name, interface status, is it up or down port, the port number, or name of the interface, the VLAN ID. Everything that you see here is discovered automatically. Transmission speed, duplex, half duplex, counterpart. Wow, how damn cool is that? You also see On the layer 1 level, which switch, as an example, that endpoint is connected to. So the counterpart is exposed using the device ID. Just as a quick update, if you check out any of these devices, I just pick a random one here, then in the device profile, you will have this connectivity section. And what you can see here is, so this device has two network interfaces, X1 and X2, and you see what is it connected to. This interface X1 is connected to this particular device here on that Ethernet IP port number 1. And then the same thing for the second interface. Oh, it's connected to that other device. And here, down here, you see that quick topology of the network neighborhood. Okay, so what you see here in this table, this is what we have been, or what will be represented in here. Okay, so the counterpart, that's the device ID of the remote device. And you remember, in OTbase, device IDs are unique. That's a guarantee. So if you have the device ID, you can then pull the information for that other device and put it all together. Remote port, remote description. So then we have a software object, and just to keep in mind, this is all associated with one device. All of this data is tied to one device. So there you have, again, another list, because it can have multiple entries. For an automation device, you usually only see one entry. That would be the firmware on this device. For a Windows box, you could see hundreds of entries, okay? Because you will see all the operating system version, you will see all the installed applications, you will see all the security patches that are installed. So that list can be quite long, and you will see examples of such data in a couple of minutes. So here you get the software category, software type. Is it a firmware? Is it operating system? Is it a patch or something? The vendor name, the product name, the version of the software, obviously very important. Think about operating system versions, installation date, end of support. This is another item from our metadata push. Safety certification, description, product lifecycle stage. Is this still being maintained by the vendor or not? All this data discovered automatically. So in real data, you will see that in a couple of minutes, you just get a shit ton of entries in that list. Oh, next thing, that's also quite a banger, right? Vulnerabilities. So you get a vulnerabilities object, where you will be presented all the known vulnerabilities that affect this device. No need to worry, is this real or not? There is no probability, there is no likelihood. In OTbase and in real life, such a thing doesn't exist. CVEs don't come with a likelihood or a probability. So once that you're able to exactly establish the installed software products that you have, you will be able to exactly tell if that vulnerability affects your configuration or not. So that means also, for if you consider Windows PCs, you will not see for a Windows 7 installation CVE end of life. That's it. No, you will see all the vulnerabilities that affect this particular configuration, which are usually in the thousands of a typical Windows 7 box. So you will get an entry for each CVE with the CVSS base core, with the severity, with the priority. That in OTbase, we have an additional field. So severity comes from the CVE definition, and that is something that is assigned by MyTree. In OTbase, you have an additional field, priority, that defaults to the severity. But as a matter of fact, many users think, well, MyTree is really a bit off here. So for us, it's not a 10.0, it's probably a 7.5. Okay, so then you can express that in this priority field, and you will always get both data items, so that then the user or the receiving application can decide what to do with that. Publication date, KEV, indicates if there is a known exploit for the CVE. So if the KEV field is set to yes, you know what that means. There is a known exploit, and you would probably need to deal with that particular CVE in a more timely manner. CVE fixed indicates if the vulnerability is fixed for this device or not. So that means let's just consider an example where in a Windows PC, well, you know, somebody applied the respective patch, then you would see the vulnerability still be called out, but the fixed field would be set to yes, and then you no longer have to deal with that. Compliance. Oh, that's another interesting one. So in OTbase, you can define any number of policies. So that an example for a policy could be must run particular version of an antivirus solution, like must run Carbon Black, must run. Oh, I just wanted to say the product with the C and the strike at the end. So probably I reconsider, must run McAfee or something like that, right? And then if you assign the policy to a given set of devices, then OTbase will tell you automatically if they're compliant or not. And you will see that reflected also in the data that you can export. So you would see the policy names called out here, and a compliance field, which is true or false. That's the neat thing about compliance and audits. An audit always implies that there is a decision to be made. Is this compliant or non-compliant? It's either or. Okay, so that is something that many people in the cybersecurity space are not aware of. And when you talk about an audit always has a definitive result, and that is either compliant or non-compliant. Do you pass the audit or do you fail? Modules. This is where you would see all the I/O modules of a control system rack exposed with their various versions, types, installed firmware version, etc. Okay, serial numbers, you name it, the type, the category, everything is going to be exposed here. And because a control system rack can have more than one slot, this is again a list. Then you have an extended object where you will see a couple of custom defined fields if the user has defined some. So in OTbase, you can extend our data model if you think, well, these Langner guys really forgot something that's super important for us. Well, then you can just create a couple of additional fields, and you will see those fields with the values for that particular device exposed here. Next object, admins. For Windows PCs, we also expose the local administrators. That's also associated with audits and compliance. So you might want to check for any stale accounts, etc., with administrative rights, because you might probably want to delete those. Last seen, timestamp when the asset was last seen by OTbase discovery, and then the name of the discovery node. In a typical OTbase installation, you usually have dozens, if not hundreds, of asset discovery nodes. And don't confuse that with sensors, with hardware sensors, because OTbase is software only. So this just means you have somewhere in a particular network, you have a process, a service running. That service is OTbase discovery, and that is periodically, every 24 hours, waking up, doing its thing, and then reporting the results back. And sometimes you want to know seen by whom, because a device can and is sometimes being discovered by more than one asset discovery instance. Okay, then the monitor that is related, the particular nodes that monitor this particular device. Okay, so that gives you an idea of the basic structure of such an object, such a data object, and you will see it in real life in a minute. Just want to just want to remind you once more, this is publicly available documentation on our documentation page, support.langner.com. And now let's see what we can actually do with this there, or how do we actually get this data? Well, you could get it by two different means. So First, very simple, in OTbase inventory, for whatever you have selected here with your filters, you can simply press this button JSON export. And then you will get what you see here in a JSON file. The other more common technique is, well, you just use the REST API. And this is documented here. So in this integrators and developers section in the documentation, you have this chapter, the OTbase REST API. And one particular topic here is how you can retrieve device data. And you will most likely have guessed it already. You're using a GET method for the REST API endpoint. And then we have a couple of examples if you want to do it using Postman. And then what kind of modifiers you can use, what kind of filters. So do you want to get the data only from one device? Do you want to get the data from all devices? How many data items do you want to get at once? This means so the endpoint supports paging in order to allow you not to overload your receiving applications. Then we have a couple of search filters for just limit the result set to a particular location or a particular OT system, and so on and so on. So now let's get to the real data. And what I would like to do is to show you how super simple this all is, because I don't even need to write a Python program or something like that. I can do it just using my browser. So in the URL that you see up here, I just add API /v1 for version 1, and I am going to use the devices endpoint. So the REST API comes with a couple of endpoints. What we have discussed so far is all associated with the devices endpoints. And when I do this, then bang, and then I get all that stuff right away. Let's click the pretty print button. And now I think it makes a lot more sense. What you see here now is obviously the same data structure that I have explained earlier. And this is how it looks like in real life. By the way, I realize that we are about time here, but I will continue for those who have different obligations. Just remember, all the webcasts are recorded. So if you want to go back and check out the recording, just go to our YouTube page, for example, or on LinkedIn or X. So you will always be able to go back to those webcasts. Okay, so let's go on. This is how it looks like with actual data. You remember, this is all we had discussed earlier. So you have a description, you have a manufacture date, installation date, warranty information, if it is set. So if it's, for example, this is particularly important for Rockwell devices. If this information is set by the manufacturer, then it will be automatically extracted via Ethernet IP. So you will set you will see the manufacture date automatically, which is super important and helpful if you consider Rockwell product notices, because they will always tie, or most of the time, they will be tied to devices with a specific manufacturing date range. So then you have zone information, modified, etc. So then now we are getting to the hardware object. Oh, that's a schematic IPC. That's from Siemens, type server, category computer, order number, description, vendor link. All that is exposed automatically. So in other words, with that data, one thing you could do if you wanted to, well, you just write your own UI for your OT assets, for your inventory. If you don't like what you see in OTbase inventory, well, you just be my guest, just write your own UI. But certainly, most of the time, this data is then processed in different ways. So it is pushed into a different platform, such as a different CMDB or something like that. Life cycle, end of life. So all that information is discovered automatically. You see the location. And this is what I said earlier. So there is a difference between the exact location, which in this case is the server room 2 in the electrical workshop in the Flatrock site that happens to be in the United States. The reference location is abbreviated. This references the site, and that is just USA Flatrock. Then we have physical processes that are associated with that device, any tags, any operating system version, but we will get to that later. So this is the OS firmware field. This is just for convenience. So we will get to the software object later. Then we have all the connections that we had discussed already. So you see the network group, that is something that the user assigns manually, because this is not something we could discover automatically. In this case, it's a non-real-time I/O network type, if you will. Medium is copper, and you have a network address, the counterpart, blah, blah, blah. And so this is an example of a device that has 2 network interfaces, and you see those are exposed in a list with 2 entries. Then we have the extended section. Remember all the additional fields that you can add to the standard OT-based data model. And anything that you have set there is now exposed via the REST API. So in this example, we have mean time to recover in hours that some engineer has added to our data model, and somebody has put in a concrete value here, which is 28 hours. Then we have an SAP equipment ID. This again is not standard OT-based data field. This was added by a user. Okay, and then the next entry starts with another device, ref. So this gives you an idea how it looks like in real life, but this is only an excerpt. So this is not the full story. Because if you have followed closely to what I have been discussing 10 minutes ago, well, there were additional fields. And if we want to see those additional fields, such as the whole list of installed software, such as all the CVEs, all the non-vulnerabilities, we don't expose all that data if you just talk to this endpoint, because there is a chance that you or your application might be overwhelmed, because once that you enter software, and especially CVEs, well, you're talking about a whole new quantity of data. So, but now we are going all the way. We modify our query by adding include equals all. We go all the way. Just buckle up. Now it's getting really tough. Okay, our next query is running. So let's see what we got. Pretty print on. Same object here. And guess what? Now we have a software object, this list that I mentioned earlier, where we see all the installed software, not just the operating system. We knew that already from our OS firmware field, that this thing is running Windows XP. Not something to be super concerned about, because that thing would most likely have been unaffected from the CrowdStrike disaster. Good news. Just saying tongue-in-cheek for those who don't understand irony and humor. So we knew that already. Discontinued lifecycle, CPE is automatically called out here. And then we have a whole bunch of applications. We have step 7 installed. We have 7-zip installed. And usually, so in a real world environment, and you will see also examples for it, you will see hundreds of installed software applications. And then, there are the vulnerabilities. Modules, by the way, so this is the I/O module. Since this is a Windows PC, well, there are no I/O modules. For a control system rack, you would see a list of installed I/O modules. Now the vulnerabilities. So everything is called out here. And that goes back to 2001. Well, how cool is that? We are talking about a Windows XP box. So all that good stuff with the KEV field, with the base core, with the publication date, fixed is false. Oh, that's bad. We probably need to take care of that. And so this gives you already an idea. Well, this list is really, really long. Usually it contains several thousand entries. So let's just use the scroll bar here and see if we also have something more interesting. Let me do something. Let me do this here. So we don't do the exclude all. We do the include software. So let's get rid of the vulnerability information. And let me just give you an idea about a more typical software object for Windows PCs. Category application. That's way too little information here for this device. Category OS, Microsoft Windows 7. Application, what have we got here? WinCC, wow, now we are talking. With its version, etc., with the CPE. Windows 7 Professional, 7-zip, McAfee. So usually this is going to be a couple hundred entries. And let's see if I find a good example here. Connections, device ref, connections, context. No, I should have prepared this a little bit better. So let's do something else. Let's just focus on the modules. Include equals modules so that you get an idea how that looks like in real life. Pretty print. Let's see if we find a good control system rec. Network ID, blah, blah. This obviously is a switch with a ton of networks, of interfaces. Also interesting. Look at all those network interfaces. I love it. Okay. Ton of network interfaces. Who is this guy? Let's scroll up. Tags. Okay, a US Stratix. All right, and so you see the ton of network interfaces. Good. So this gives you an idea of all the things you can do. And for a more in-depth documentation, please refer to support.langner.com, where you see the actual reference for this, how what fields exist, what the format of those fields are, along with a ton of examples, also with examples for how to use this in Postman. We have created a Postman collection if you actually want to follow through. So if you have an operating or OT-based instance, then this gives you a very good entry and a quick entry into how you can pull all this information from your assets and then post-process the data. So this makes integration super simple, as you can imagine, because of the contextualization and because of the way that the data is represented. So it would be extremely difficult to impossible to put all of that in a two-dimensional table, such as in an Excel table. But once that you take advantage of structured data, which is certainly very easy to do when you express the data in JSON, then it gets really powerful. Then you can see all these various contextual dimensions. And that is what I wanted to point out to give you an idea how this contextualization makes all of the difference. And that is not limited to the user interface. When somebody wants to just using the mouse, wants to do some quick filtering, wants to do some analytics, that extends into integration. So basically, you should consider that all the data that you see in OTbase can be exported via the REST API, or if you just dump it to a JSON file. As I had shown you earlier, there is always this this button. Let me go back to the screen again. So in the device inventory, and also in all the other various lists that you get, you always have this JSON export button. If you prefer, you can also export it to Excel, but you will lose information. That's the important point. Excel will not allow you to fully represent all those various complex contextual dimensions. So like, what is this device actually connected to? Which networks is it on? And if you want to do that, you use the JSON export. Funny tidbit here. If you look at your global OT asset inventory in OTbase, in the devices inventory, and then you click this button, this is going to produce a JSON file that in your case might be more than 1 gigabyte inside. And guess what? That is your full OT configuration. You can put it on a USB stick and just put it in your pocket and go home. You have the full OT configuration with all the installed software, with the network connectivity, with the physical process associations, with everything. And just imagine how powerful that is if you want to do any post-processing, any more sophisticated analytics that you don't already see readily available in OTbase inventory. Just imagine, because now we are talking about data mining. You have the data in your hands or in your pocket, if you will. You can dynamically extract the data via the REST API, and then you can post-process the shit out of this data. And you're always, if you're using the REST API, you're guaranteed to look at current data, which is certainly not the case when you use the USB version, so the USB path to the data. But anything you pull from the REST API is current data, and you can then post-process that data in any way you seem fit. So that is what I wanted to cover in this session. Remember, you can ask questions if you just drop a comment in whatever platform you're using. So I will take another 2 or 3 minutes to check if you have any questions or comments or criticism. Don't be shy. Just let me know what you want to focus on, and we're going to address this. So what we want to achieve with this webcast series, remember, it's every week, every single Tuesday, is we want to give you an idea what OT asset management really means. What different facets, what different dimensions it actually contains. And we do that by focusing on individual puzzle pieces in each session and try to do something like a deep dive, so that hopefully over time that bigger picture emerges in your head. And the bigger picture simply is what OT asset management is all about. It's not just about the vulnerability management. It has so many different aspects. And what we have tried to do in OTbase, and I think what we have achieved successfully, is to represent all those different dimensions. And you can approach the data from any kind of angle, and you will get quality data, actual data, like up-to-date data. And then you can use that for very different use cases. This is probably something that is very characteristic for OT asset management, or for an OT asset management system. There are a ton of different use cases for different stakeholders. So you could say, well, from a process engineer to the CISO, they have their very specific use cases, but they are all looking at different aspects of the data. Okay, so here is a question. Let's focus on this one. Thank you for the insightful chat as always. From an anonymous LinkedIn user, is there a way of tying the priority of a CVE to the exposure or a zone automatically, something like a suggested priority? For example, if the severity from MITRE is critical and the asset exposure tag was public, you'll prioritize it accordingly. I get where you're going with this. And this, in my opinion, leads us into a very, very interesting topic. And this is, now we are going deep into OT vulnerability management territory. So the biggest problem in OT vulnerability management is, well, the magnitude of all the CVEs. You're not talking about a dozen vulnerabilities or a couple of hundred vulnerabilities. You are talking about hundreds of thousands of vulnerabilities. Sorry to break it to you. And if you don't see those hundreds of thousands of vulnerabilities in your existing OT security solution, sorry to break it to you, but then your OT security solution is useless for OT vulnerability management. So that means that for OT vulnerability management, the biggest problem that you need to solve is how do you arrive at meaningful prioritization. And therefore, we have one tool that we give you is this priority field. So anonymous LinkedIn user, you are onto something, I tell you. This is one reason why we have introduced this priority field. So it defaults to the severity assigned by MITRE, but you can change this. And now our anonymous LinkedIn user has a very good idea. Well, what if I could use some automation here? And that is exactly how you would use it in a more mature OT vulnerability management scenario. And the way you make that happen in OTbase, and trust me, I will come back to that in depth next week. Same time, same place. That's a threat. I will come back to that topic. The way you address this, all these fields, including priority, including the security target level, they can also be written via the REST API. And that means that you can implement all kinds of sophisticated algorithms that represent your corporate approach on how to prioritize vulnerabilities. I will give you some ideas next week, I promise, but you can change that and fine-tune that in any way you want. So you can model your existing corporate approach to prioritizing vulnerabilities, put that in a Python script. That Python script sets the priority data accordingly, or the priority values, okay? You can also set the security target level. There is another field that is the risk score for a given vulnerability. So you can use your own risk scores, and certainly you don't want to manually type them in for your 500,000 vulnerabilities. You want to use automation. And that is one reason, so I'm very glad about this question, because that shows you how powerful this data interface is. Because now you can just write your Python script and do whatever you like, which certainly would not go very well inside a UI, such as OTbase or any other platform, because in Python you can do anything when it comes to the algorithms. So you do all your computations, you have picked up all the information that for your specific case is deemed relevant. That could be the network zone, that could be the criticality of the device. You compute that, you put all of that in, and then you spit out a priority, or you spit out a risk score, and then you work from there. And then you enter that into the remediation task workflow that is already in OTbase. And if you haven't seen it, I have done a webcast on the vulnerability management workflows a couple of weeks ago. So if you just go back to our YouTube channel, you will most likely find it rather easily. And this is then how it all ties together. So again, very good question. And it points to exactly what you need to do. When it comes to OT vulnerability management, you must use automation. Otherwise, you are drowning. You're drowning in your backlog. This gives me another opportunity to point out, well, if you think, let's focus on that new vulnerability that just dropped in from NIST, you're doing it wrong. The latest and hyped up vulnerability, that's not your problem. Your problem is the gigantic backlog that you haven't seen so far because you have been using OT security products that don't show you that backlog. So once that you have come to that realization, automation is the key, and we will focus on OT vulnerability management again next week. See you there, same place, same time. Bye-bye.